Hello everybody and welcome to today's Shaper webinar. As said, today I will talk a little bit about the improvements and new additions to the Shaper 2D sketching engine, and I will also explain or illustrate their function by showing particular small details of the objects we see here. So with all this said, let's go ahead. And oh my god, never mind, sorry. I flunked for a second. So what's new in the sketch engine? For those who know the older version, you see actually on the left side we have now a sketch tool, and we have dedicated shapes. For example, the pen. Well, with the pen we can obviously draw our lines. We have the rectangle, and the rectangle, there are two ways how we can draw it, from the center to the corner and diagonal. We also have a circle, and we have an ellipse tool. So the ellipse tool is pretty nice. When you start drawing, you can see that we can specify obviously the size and also the width. So for example 4 and 5, you see we can play with the way how this ellipse actually looks like. And when we tap somewhere else, so the dimension goes away, and there, oops. You have then also the midpoint, which we can move around, and you see the dimension stays with it. And there we have this corner point. And with that point, we can actually rotate the ellipse. So it's pretty nice way how to adjust your ellipse. Another obviously interface-wise big improvement and change is on the right side. You see all the constraints. So in this version of Shaper, the drawing tools and the constraints are changed, and they are set so that you only see basically the tools you could use. The first option, auto constraint, for those who are not familiar with it, this basically means when I draw a vertical line, let me turn on my snap to grid. There, it adds the constraint automatically. If I turn this off, the constraint is not added. So this is actually very helpful if you want automatically all these constraints to be added. And to make things easier to read, we also have the ability to show and hide the constraints. The other new addition to Shaper is actually the curve tool. So to draw a curve, we can be in pen mode, draw a line, press with the pencil, press and press. And currently I have the spline tool selected. To switch between this the fit point spline and the CV spline, you can go to here and then switch between the two options. I will create a curve here at the control point. Tap, 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 and there it is. As you can see, the two biggest differences is with the CV curve. We adjust the way how this curve flows by manipulating the CVs. And with the fit point curve, similar to kind of like Illustrator or other vector tools, we're actually working with a node or a point which we move, and the curve always flows through it. And in addition, here we also have those control handles which we can activate and manipulate. And then you see that this will further adjust the flow of the curve. Now you might ask yourself, well, where is the difference between these two curves, or when should I use which one? From my experience as an industrial designer, the fit point curve, so the first one, is very good when you want to have very even and smooth curves. Because as you noticed, when let's say I select this point and move this handle, the whole curve actually updates. So think about this as a stiff material that we bend over these corner points, and it always wants to relax. The CV curve, however, is very good if we want to do more local manipulation and actually want to have, for example, a transition like this, which would be a little bit more difficult to do with the fit point. And this might also be a question of preference, but I found the fit point very good for very smooth, simple curves, and the CV always very good for more complex curves. Okay, so with all that said, let's go and take a look at the sketching engine. And this first object I would like to create is the book rack. Good, so let's take a look at this book rack. And I decided to do this type of a quick modeling exercise for all those who are new to Shaper and also the way how the sketch engine works in it, because the sketch engine in Shaper is like a smart one that can be constrained, unlike, for example, the sketch engine inside a surface modeler like Rhino or Alias. So I go to a front view and I will go to centimeters for my units. Very good. And I would like to create a book rack that is, let's say, 1.50 m wide and 2 meters tall. So let's say I go to here and draw myself a line up. I also have auto constraint turned on. 200 centimeters for 2 meters. And zoom out a little bit. I can move that constraint dimension to the left. Let's draw a line to the right. Let's keep it 125. Go straight up and move it over to there. Very good. So with these dimensions I have here, I can adjust the height and the width of my bookcase. And I will start with the outer frame. I will now lock this sketch to the grid, and to prevent the rest of the sketch to move, I select this as one point and click lock on the right side. This basically means if I select this point and I try to move, this rectangle is stiff. So that's already the first difference to non-intelligent sketch engines. The software always tries to solve the relationships we're creating. Let's create an offset surface. So for that I need to create my offset curve. And with the offset tool, 10 centimeters, let's give this a nice thick frame. There we are, very good. In here, now the trick restarts. At one point I would like to be able to adjust the sketch very easily without much extra work. So this line and this line I would like to be centered, and this line and this line I would like to be centered. Because now we have midpoints, one of the easiest ways is we draw a line from midpoint to midpoint, for example. Then I also will say this midpoint be horizontally and this point be vertically constrained. Very good. So with that done, let's see what happens when I adjust it, and there's some misbehavior happening. What's going on here is simply this line does not have a horizontal constraint. This one does not have a vertical constraint. And that already solved it. Very good. Now how can we quickly adjust the width so that the distance is always the same? These two edges I can each give a dimension constraint, but I'm kind of lazy. I only want to do this once. So let's take a look at this. I give this 10 centimeters, and we can actually make lines equal. So I select this line, then I select this line, and on the right side I select the equal constraint. There. Because these two lines are now set to equal and one line is dimensioned, I can adjust this. And you see my frame adjusts. So super easy. I could go ahead and say make this bigger or make this smaller. There, very good. Let's throw into shelves. And also there we would like to have everything set up with minimal work. We can adjust everything. So this was actually a spline, so be careful. I just draw two lines, left and right, two more lines there. Actually, let's make three there. Be careful when you draw the lines that you don't go up and down, so it's not becoming an arc. Vertical, vertical, horizontal. No? See, I'm just specifying that these lines should be all horizontal, so they can't rotate anymore. One last check if there's anything else that's breaking. So this line here needs a vertical constraint, and these actually needed horizontal constraints. There, very good. Okay, nice. Let's try these endpoints. The reason why I'm moving these endpoints up and down, I wanted to see if these points are actually glued onto the edge, and they are. We also see this by the icon on the left. The right is the lock, and the left, that means this point is coincident constraint to this line. Very good. To make these lines have the same distance, here we can do exactly the same trick we did before. We make them all vertical so that you form the same way. Then we can select two lines, say equal, select this line, and say equal. And I could give this line, or to make my sketch easier to read, I simply select this and say 10 centimeters. There. Maybe 10 centimeters is too much. Let's make this 5. Very good. And these two spaces, now I would like to be exactly at the same height. So we know I can do now exactly the same. And just draw a line from point to point. Also here again, set everything up, and then add my equal constraints. So it's a little bit of upfront work, but now I have the ability to very quickly create different variations. So if I pull this one down, you see everything nicely flows. So this is pretty awesome. Very good. To create now the model, we can select actually these two parts and extrude this one out. Let's say 60 centimeters. I would like to have kind of like a checkerboard element there for the back, and maybe this one because that's bigger. Move this one up, let's say 2 centimeters, that's enough. And then those two I select and extrude them up to, I could say 60 so it's flush, or maybe we make it 58 so there are a tick inside. Very good. Now in terms of process, if I want to create a different model, I could go ahead to go move, go to groups, select my group, move it to the right, let's say like there. Very good. And maybe move this one to there. And then I repeat the whole process and make myself another model. So as you can see, there was a little bit of upfront work for the sketch, but now it's very fast to create variations. And we just did this by using a smart approach to constrain our sketch via dimensioning, locking points so that the sketch doesn't move, using the horizontal vertical constraint and evening out distances via the equal command. Okay, number 1. Let's go to this one. This is another nice example to show you how sketching in a program like Shaper is different than in non-parametric CAD programs or programs that don't have a sketch solver. So I will start with a new design, and I have actually the object right here. So you will see this on the Instagram feed, and it's always good to have a reference object, particularly if you want to learn how to model, so you could measure everything. So we have 65 by 75, so a rectangle. I will set my units to millimeters, it's easier to work, and then I will go to a top view. So 75 by 65, let's say 60 by 70, fits better to the grid. So I can draw horizontally a line and say 70, then I draw vertically a line 60, draw my other line and line there. Very good. Now how do I center the sketch? Here's another little nice trick. From the grid I draw a line that connects to a midpoint of one edge, and this point is lined up with the x-axis. That's the center of my sketch. So this point I select, lock it, then I can select this line and say be horizontally constrained, and that pulls the geometry down and everything now is locked. Very good. I could also prevent this rectangle to further move, so these 2 points I could lock. Now the only thing is left is I could adjust, for example, the length. Very nice. So the spatula has a rounded corner. I could put this into the sketch, but that makes the sketch way too complicated. A very good approach when you start to learn how to create all these sketches and the geometry, try to really create the bare minimum of elements for the sketch that makes sketches easier to manipulate, because the rounding we can do via geometry tools. So we select that surface and extrude this one up, let's say 6 millimeters. Now this one corner is rounded. With the pencil I can select that corner and simply round it. Let's say 20 millimeters. Yeah, that's a good rounding, gives me enough space to flip up the egg omelette. And this corner here I would like to round a little bit to, let's say 10. With 10, now I would like to make this one 25. So here I can simply click on the fillet and then it gives me the rounding or the value of the fillet. Same also with the height, if I want to make this 4 or 6. Pretty awesome. So here's another nice thing. I will show you how we can do the edge detail, because this edge is actually filleted and then also chamfered. So swipe here to the right is fillet, and then swipe to the left is chamfered. But I have to select all the edges here so that the chamfer goes around the whole corner. Very nice. Okay. The only downside with this is the chamfer is very even. Well, how do we do this if we want to do an uneven chamfer? Well, we can create another sketch and then combine this with the sweep tool. So check this out. With the pencil I will select the surface with a finger tap on it and then tap somewhere else, and I draw myself a line, and when I hit this edge, see edge pops up, it will snap to that detail. Let's move this one up there. Let's maybe bring this to there so it's at a different angle. Very good. to see what we did, let's hide the group. And there we can see by drawing the line to one object edge, it projected this edge in and also created this edge. Now this sketch I can use by using the sweep command to sweep along these edges. So I select edge after edge after edge, click OK, and then I go to Tools again, Subtract. This object I would like this other one subtracted from. There. No, this can happen. It's because I built the surfaces perfectly flush, so I failed one of my biggest notes always to overbuild. So let's go one step back. Oh, that was one too much. Very good. And there we are. So I would like to go back to the sketch here, double tap there. And what we will do now is we will overbuild this a little bit. So I add a little bit of material to it. This way cutting surfaces do not intersect perfectly with the original object edges. So in this case we do exactly the same. I select both faces now and then sweep it along these edges. Very good. That also makes the selection of what to subtract a lot easier. There. See? Perfect. So a nice combination of sketching and modeling elements. Let's go back to the front, because the next thing what we have to do is we have to work on the handle. And the handle is at an angle. And here now I can show you how I'm going to plan out the sketch and deal with the rotation. This is the distance from the spatula to the handle is like 50 and 60. I create myself some basic helper lines somewhere so they give me some idea where stuff is, and I know the end is also 120 or 150 something high. Very good. So from this point going up and from this point going to the left, there my handle would be, and there. Okay, very good. Now at this point I will lock, and we'll show you why. Let's start by drawing a line. This line I would like to be perpendicular to this line. You see, when I select both lines, then it gives me a dimension for the angle. I can do the perpendicular condition this way, or I can simply select these two lines and say perpendicular. What's pretty cool is if I select this point now and move it, you see I rotate the line and the other line rotates with it, but you see the dimensions change. So we have to specify also our dimensions. So let's say here we make this 6. Very good. Okay, now I can select this point, but I can only rotate and the rest stays the same. Very good. Let's make a quick transition. I would like to have a handle and an arc. So somewhere here an arc. This arc center point I want to glue onto this line. So you see I drag it onto it. Now as you can see it has the coincident constraint, which means this point always stays on it. We can also specify the radius. Very good. We can also set here a condition so that actually this arc terminates perpendicular onto this line. Very nice. And let's make a nice smooth curve, a transition. So I will, in this case, use the CV, so control point. So from there I start drawing, click, and then I click and I move the last point to there. Now what I would like to do is that this flows perfectly into there. So I select both curves, click tangent, and then you see here I have this control point which I can move also up and down, and that actually specifies the transition. Okay, and here this curve I would like to terminate tangent to an edge that is there. So two lines perpendicular. To make sure this line deforms predictably, I give this also a length dimension, and then these two elements we select, tangent, and to make sure that also these points do not move around, also here I can, or better I have to give them a value too. There. So if I select this point now and move this around, let's see how my sketch deforms, and we can see that there's something happening over there. So what is left is that this point can move around in ways maybe I don't necessarily want. So what could we do there? There are multiple ways. We could specify distance. And there, see? That's all good. With this distance, I move this point further over and can create my design. Very nice. Now, let's move this to here. Very good. And to prevent this element to rotate anymore, I can also lock it. There. To create a handle, let's go to Tools and Revolve. There, there, there. There we are. Super nice. Okay, maybe that's a little bit too thick. So let's delete this one. Let's go back to the sketch. And this maybe we can adjust. We also have to adjust this one. Yep, there we are back. Okay, so you see two values needed to be adjusted. Let's do the revolve one more time. Yeah, that feels better in my hand. Very good. Now it's time to create the connection between the handle and the base. I will hide both objects, and here I will create a new group, have the group also activated, and I would like to build now a spline. So here I will start from there, 1 point for tangency, 1 point for detailing, and then 2 points for tangency again. Very good. Okay. I will go to sketches and hide those I don't need. Like this. Okay. Similar to with the handle, I will draw a line. These two are now tangent. This one now I can lock. And this point I can move around. This point I can move down if I want to there. And this point I have to move to there. And then these two elements I select, tangent. And with this point now I can just decide how far do I want this curve to go. With this one I can stretch this a little bit more. Very good. Okay, so the one was extrusion, the handle was a revolve. How do we create something that, kind of like what you see in Instagram right now, is arced? The transition, that's metal. I will go to top view and then rotate a little bit. Let me show you what a construction plane is. As long as we have views which are horizontal or vertical, that's very easy, but if we want to sketch something that's maybe at an angle, it's more difficult. We need the construction plane. So we go to add construction plane, offset, and I would like to have a plane that runs perpendicular through that curve, perpendicular to curve. Select this curve. You see now I can slide this one up and down. There. For simplicity reason, I will move it to the end. That's very good. With the pencil I can select it, with the finger double tap, and then you see it zooms actually to that position. Let's take a look at where we are. Okay, there it is. So this arc is a little bit too low. So I will create, let's say, a small rectangle from there to there. I just plus minus blocked out the location. Now I can hide these other elements again, so it's easier for me to draw everything there and there and there. This is maybe a little bit too high, so let's drag everything down. What's the width? 1.5. Can maybe do this with 2 millimeters material thickness. What's up here? Maybe 6. I use the grid a lot, and then even numbers, because you see here this way I centered the rectangle by moving it 2 millimeters to the left. And the only thing I might have to adjust now is with this done, this spline is actually not correct. So I switch back to the front view. Very good. Hide all this. This line is locked, so I unlock it. You too, thank you. I guess I have to do this here manually. It locked everything, good. And then I can move this down. You see that moves the whole sketch. Then I can zoom in and that looks pretty good. Very nice. So a nice mistake here happened. This one line, this one here rotated. No, not that plane, this line. But because it is tangent to the curve, all I have to do is select the horizontal vertical constraint and we're good. So with all this done, now what we can do is I go to this group so it's easier to see. Tools, and then we go to sweep. So this profile I sweep along this edge. I could also properly go this edge, and because the sketch tangentially flows into this line, I can even select this line. Now I will, just to show you what we else can do, cancel this command, just do this one more time, sweep, and say you to there, whoops, to there, okay. And then up here we can even select this face and then just extend it via dragging, because it terminates tangent at that point. So the surface, as you can see, will even flow further along it. Maybe some rounded edges so we don't hurt ourselves. There we are. Very good. show everything, go to top view, hide our sketches. And there, super easy. How are we in time? We have like 10 minutes left. Let's take a look at this object. This shows actually another really nice addition to the sketch engine and how we can use it. And what I will particularly show you is the project tool. You might see that the surface is arced, it's not flat. So how did I do that? I will delete this one, and I have some of these sketches already in there. I'm not going to recreate everything. So I just built an object. See, it's just an arc. Let's extrude it. Not very complicated. And these edges I would like to round. I measure this first 4 millimeters. So I know that then these two edges, if I round them to 2 millimeters, creates perfect domes. Nice. And now this top surface, that